Thanks for hosting this, Candace, and for the invitation to speak today. So I'll be talking about the integration of physical water data with economic data into water accounts that are compatible with our economic accounts and getting into what all that means. And I want to start by acknowledging a number of co-authors and colleagues who have been part of this working group. As we heard, this was funded by the Powell Center and SYNC, and we've been meeting over the course of the last 2 years and are just starting to get our some of our products like these water accounts finalized. So really appreciate both their collaboration and the chance to present on this work today. So what are water accounts and why could they be useful for decision makers? I start the description of what natural capital accounts are generally by looking at our economic accounts. And these are statistical standards that countries use to track their economic measures. And one of the most familiar economic measures is gross domestic product, which we can see tracked on a yearly and quarterly basis for close to a century now. And this is a really useful exercise for countries to be able to compare their economic activity, to look at change over time. But what has been known for a long time is that there's a gap in these national accounts in accounting for the natural resources that go into economic activity and that underpin economic prosperity. So as a result of that, within the last 10 years, there's been a push towards what's called the system of environmental and economic accounts, and these are designed to supplement and to better inform the economic accounts by quantifying the role of natural resources in economic prosperity. So we have something called the Central Framework, which measures things that are already included in the economy, like food, raw materials, fresh water, and tourism. And there's a specific guidance for SEA water, which I'm going to be talking about today, the application of that to the U.S. In addition to those core natural resources, there's also something called the experimental ecosystem accounts, which are designed to measure the contribution of nature in other ways, such as protection from natural disasters, crop pollination, and a number of other important ecosystem services, and to measure them in a way compatible with the economic accounts. We've been working on this as well, but that won't be the focus of my talk today. So our working group has been putting together an initial set of accounts for land, water, and ecosystems in the U.S. And these are the different pieces of the accounts that are included. And today I'll just be talking about this middle box, the water accounts, and what we've been able to pull together and what they tell us so far. So as I mentioned, the current economic accounts are incomplete. They don't account for the value of nature and its contributions to the economy or to the risk to the economy and prosperity of depletion of those natural resources. We want to be able to link that information in a very systematic and transparent way that's consistent internationally so that the results can be compared between countries. We can compare imports and exports and those types of considerations. We want to be able to assess water sustainability and to aid decision-making in the public and the private sector. And ideally, this will all improve data coordination and data quality, and we've already identified inconsistencies and gaps in places where we can improve the data collection and data synthesis processes, and we want to be able to update these periodically. Ideally, we would be able to update these annually the way we do our economic accounts. And while that's not something we can do right away, it's something that we could aim for in the next 5 to 10 years. So to give a brief description of accounts themselves, it's important to understand the idea that we have economic assets and they help produce economic value. And both the extent of those assets and their condition matters. So what our economic accounts do is they measure the value of infrastructure like factories, and you could imagine that a large brand new factory would be more economically productive than a small one that hasn't been well maintained. And in the same way, water resources provide important economic inputs, and if we had an abundant and clean source of water that's delivered at the right time for user needs, that's going to be a lot more valued than something that's degraded or depleted or doesn't have enough water available to meet user needs. And we have ways of valuing those assets economically. Water is a tricky one for a number of reasons, and I'm not going to go into the economic valuation of water today, but we'll just mention that a lot of our work has been on the physical side. We've done a little bit with water productivity, but there are some inherent challenges to economically valuing water. Accounts are fundamentally tables, and they have rules that govern those tables, so that we have different sides of the ledger balancing in effect. And so there are some standard rules that govern both economic accounts and water accounts. And for water accounts, a lot of those accounting rules are derived from the water cycle, both the natural parts of the water cycle and the parts that relate to the human abstraction and use and return of water back into the environment. So a couple of views from the System of Environmental Economic Accounts guidance. On the left side, we have a basic picture of both the water cycle and the economy and the interaction between the two. And on the right side, we've got a more detailed breakdown of those two pieces. And the green circles are places where we've been able to pull together pretty complete data about water use and water flows. The orange circles are places where we have partial data. So ideally, we would be able to quantify all these different flows between the economy. And many of the pieces of the top part of this diagram are already being put together by hydrologists and other natural scientists within USGS and other research groups. But what we're trying to do is to build a more coherent and complete picture of the bottom part of this and its interaction with the natural water cycle and why that's important. So sea water comes with some challenges, like a lot of these large-scale synthesis efforts. We have some data that are collected at the watershed scale and other data that are collected at the state or national or county level. So we have that physical versus political boundary problem and question that makes for a challenge. Identifying and measuring the stock of water has some challenges, which I'll talk about a little bit later. There are various issues with reporting and the consistency of it and how it's aggregated. And there are some places where we just don't have data. But what we've been able to do through this project is to identify those places and hopefully produce another set of arguments and another reason why it might be valuable to collect more and better data. So the accounts themselves, there's a number of different accounts that are itemized and described in the SEA water guidance. And the three accounts that I'm primarily going to talk about today are physical supply and use, water emissions, and water quality, as well as water productivity. And this is in line with what the SEA recommends. Physical supply and use is really the starting point. And then moving on from there to figure out what, if we're doing this in a country like the U.S. for the first time, what are the most decision-relevant accounts going to be, and what accounts do we have data for, and moving on to complete accounts in that way. So what I'll be presenting on today is our first estimates, both at the national and state level, for these four accounts, plus an expert elicitation we did about linkages between water quality and the economy that we hope can inform future research to identify data gaps and to really lay the groundwork for future accounts so that we build time series that are meaningful and we have new accounts when data become available. So starting in on water supply and use, this is a supply and use table, or this is the start of a supply and use table for the nation, just showing the four most recent data sources, primarily drawn from USGS water use data, but we use some coefficient methods to fill in some gaps where we felt confident in doing that, including golf course irrigation and evaporative loss from hydropower reservoirs. The USGS Water Use Survey, of course, is a great, consistent data source that's been done every 5 years, and we see on the bottom right here a graph showing the trends over time, and we see since 1980 a declining total water use and more steeply declining per capita water use because we've had less water use with population growth. That has continued through 2015. So what we do in this table is we have broken down those codes at the top are industrial classification codes, which are used with the national economic accounts. And what we're trying to do is to get those economic accounts and our physical data to speak the same language. So we can then look, this is an example at the state level of for a given year, in this case 2015, and basically what is the abstraction, the transfer of water from one economic user to another, and the returns of water back into the environment and the consumption. So all of these have specific, all of these rows have specific accounting rules attached to them based on the SEA water guidance that let us calculate them consistently. And what this does is lets us track this physical data in a way that's compatible with the economic data. One of the issues we face here is in comparing the USGS water use categories, of which there's 8 here that have been standard since the year 2000, and trying to compare those to these North American Industrial Classification System codes. And those are the codes that we have all sorts of economic data for, and we can start to compare them to economic productivity, GDP, jobs, et cetera, all of the data that are in the economic accounts. So you can imagine aligning those is both really important, and you can see the alignment is difficult for a number of reasons. For example, with industrial, USGS measures industrial self-supply, but we don't have good measures of industrial use from public supply sources. So we have some problems in crosswalking industrial use to the economic data that would correspond to its water use. We'd also love to be able to go down to a finer scale of resolution of these different types of industries, but in many cases the physical data don't yet allow it. So again, looking at some of these trends, these are drawn from work that builds off the USGS water use data, but makes a few additions to it. We have total water use at the state level, percent change in water use. We can show water use from groundwater and how much groundwater use is increasing, which is maybe one of the most interesting water use trends, that overall we're using less water, but we're getting more of it from groundwater, and how sustainable is that water supply. We can look at this in a number of other ways. So this on the left breaks down water use by the different industries at the state level, and we can see, not surprisingly, thermoelectric use dominating in the east and irrigation water use dominating in the west. The west, of course, has a lot of hydroelectric power use, and we have a little bit of hydroelectric water data, but not enough to really paint a full nationwide picture. So as a result of that, we also show what happens when we pull out thermoelectric water use, so that we get a more consistent nationwide picture of the different uses. And we can see here in the east in particular how industrial or manufacturing and irrigation do play a role in some eastern states as well when we look at non-thermoelectric use. Moving into water quality accounts, we of course here rely on NACWA data, which pull from a wide variety of sources, and this report from last year was our primary data source, this decadal water quality trends data set. So we have the water use data every 5 years from 2000 to 2015. Our first water quality account, we are looking at that decadal period from about 2002 to 2012. And we broke the U.S. up into a number of water climate regions based on EPA water and climate classification at the state level. And we looked at the number of different water quality monitoring locations where water quality is stable, increasing, or decreasing, and trying to pull out trends there. Again, while there may be less of a trend at the national level, for some regions we see more water quality monitoring sites with improving or worsening water quality over time. We have similar data, of course, for groundwater, also from NACWA, and really there's not a whole lot more we're doing with this at this point than just to represent it in a more accounting compatible way, but we want to be able to show not just water use, but also water quality and how it's changing over time. So we've produced a number of maps of some key water quality constituents, and from here you can see, again, while the national level picture may be ambiguous, there are some states where we see more improvement in particular water quality parameters over this 10-year period, and other states where we see declines. So we've put together maps like this for 6 major water quality parameters that we have consistent nationwide data from the USGS NACWA product from last year. Water emissions are a third account we've been working on, and this primarily draws on US EPA discharge monitoring reports. This is a great data source because it's nationwide and it's pretty easy to pull the entire database. It's got a few limitations. It only includes NPDES facilities, which are a limitation on one hand, but probably the biggest point source dischargers in many other cases on the other hand. There is an issue of self-reporting and data gaps and errors, which for some states are easier to fix than others. And unfortunately, this particular database is tracked by standard industrial classification codes, which is a 30-plus-year-old industrial classification system. So there's a bit of a messy crosswalk to NAICS. And because of some of these limitations, our initial accounts are just going to report on 2015 point source emissions data at the national scale. One other key limitation, of course, which is probably self-evident at this point, is that this includes just point source emissions. We don't have, at the moment, national scale non-point source, although that sounds like it's going to change from with some upcoming USGS product. So again, you can see a similar structure to the water use tables in that we're classifying by industrial group what the emissions are for the year 2015. And if we look at this rightmost column, you can see that we are capturing most of the activity in these 15 or so major economic industries. We're missing about 30% of the solids emissions, 12% of organic emissions, but then less than 5% of the others. So we're getting a pretty good coverage of these. Water productivity is the last of the 4 accounts we've been looking at, and so what we do here is we take the GDP generated from the economic accounts and we look at how much GDP is generated per 100 gallons of water use. This is where that coarse thematic resolution of the water use data is really, unfortunately, a limiting factor. And as I mentioned, we don't have data on industrial use of water from public supply, so we can't do this for industry, for industrial and manufacturing water use, unfortunately. What we can do is we can take total GDP and divide it by national water use and look at how those trends are changing over time. You can see they're increasing. This is just using the raw USGS numbers. This is with some of the small adjustments we've made. And we can look at the value from mining and from agriculture. Not surprisingly, the per 100 gallons value from agriculture is lower because there's a huge amount of water used for water use, higher for mining. If we had a finer breakdown of water use by industries, we could do a lot more with looking at some really interesting trends. And what we're showing mirrors an early analysis. Again, this one stops at 2010, but you can see water productivity really starts to jump in 1980, again, as we nationally start to use less water, but have economic growth during that period. So we can also break this down at the state level. This is 2000 and 2015 water productivity by state, and you can see a lot of these factors are going to be driven by what's going on in the state's economy, how much manufacturing, mining, agriculture, and other water use is there. So in some of the states with more industrial base or with really high water productivity types of mining, there may be higher value. In some of the states where irrigated agriculture is the dominant water use, there may be a lower unit value of water productivity. We split this up by agriculture and mining as well, and so showing the places where there's more agricultural water productivity and mining water productivity. We were looking for some trends that might be changing in the U.S. economy, and we came up with a couple of trends like the increase in corn ethanol and more broadly agricultural intensification during the period of 2005 to 2015. And for mining, one of the obvious trends has been the increase in shale gas production from hydrofracking. And we outlined the states where corn production and hydrofracking are happening and didn't really see a big trend here. I think with agriculture, we see some of the higher value crops and the places where there's less irrigated agriculture producing greater water productivity. For mining, we have states where there's higher value products with low water use showing up as some of our high mining water productivity states. We can also look at the percent change. What states is this going up and what states is this going down? And we can see in many states there's an increase in agriculture water productivity. Mining, it's a little bit more of a mixed picture. And then the final piece that we've been working on is we have produced all this data about water use, its value, and water quality. And we wanted to at least start on making some qualitative linkages between these two. So with the help of some of our colleagues in the USGS NAWQA program and the Water National Research Program, we did an expert elicitation where we asked two different questions. One about how water quality affects the economy, and then flipped it around and said how does economic activity affect water quality? So what we might do with this in the future is we might be able to look at where there are states that are seeing a lot of water quality change, and are there potentially vulnerable industries that require a certain water quality but might be seeing change in that water quality? Are there places where particular types of water use might be able to find the water they need to provide valuable economic production? So what we did here was we had an elicitation process with 15 water quality experts from USGS and EPA. We asked about 14 water quality parameters and what their relationship was with the 8 major water users across that are included in the USGS water use report. So we also wound up getting some other suggestions from our elicitation about other water users and what the effects are and other water quality constituents. But the idea was, in a very broad brush way, is it a positive effect of some of these water quality constituents on industry, or is it a negative effect, and how strong was it? Was it a moderate, small, or a major impact? Now, we realize that, of course, this is a very, very generalized survey. We were asking about the national level. We were asking about broad water quality or water use categories. And so we don't, I don't take this as the, the sort of endpoint, but maybe as the starting point for thinking about how water quality and water use and its value are connected. And what we did when we came to consensus about these, we get a spaghetti diagram here about the strength of impact and whether it's positive or negative from water quality metrics on the economy. And this is pretty intense to look at. So we can also split this out and just look at, for instance, for a particular water user like aquaculture, what are positive effects and what are negative effects. We could, on the flip side, look at, for a particular water quality constituent like salinity, what are the relative effects on different industries. And again, this is just a very broad brush picture at the national scale. Things might look different in your part of the world, but if there was an interest in looking at water quality and economy connections, we could certainly think about how we might change or do an elicitation like this for specific groups of industries, specific parts of the country. Similarly, our second question was looking at the reverse of this, so the effects of water users on water quality. This is the overall picture. And as before, we can split this out to look at which water users have potential impacts on water quality and which water quality constituents are affected by which industries. The one account that we didn't compile but that we would be very interested in someday looking at is water assets. So how much water do we have as a nation and for different parts of the nation in different different locations of the water cycle effectively from one year to another year. So this is just a dummy chart from the SEA Water Guidelines. This would be really interesting to look at, and there's some work going on at USGS that could enable us to do this in the future, we feel like. So again, there's a lot of overlap, challenges, and synergies, I think, with USGS National Water Census and other research in the water field. There are some key gaps that we'd like to be able to measure, and there's some work that's going on which may be able to fill some of those gaps. There's this question of how we summarize the results by state or by watersheds, which will remain an ongoing issue until we start to better mesh our data from the economic and the physical side. And there's, of course, ongoing work both within our physical science agencies, but also at Census to collect better data on industrial water use, which is really exciting. This is data that won't be available for probably another 2 years, but previously our best data on water use by industries was from 1983, so Census was able to get a new question on the economic census that will give us a much more updated view of how industries use water, which will be great for informing future accounts. So this is just a summary table of our accounts, our key data sources and key limitations. I've been through this, so I'm not going to spend much time on it, but this brings it all together for where our accounts stand today and what they could look like in the future. I'll just close with a few quick slides on how other nations have used water accounts. These have been in existence for 10 years or more, and some other countries have used these quite a bit for decision making. Notably, Canada and Australia have done a lot of work on the value of water and water productivity by industries and how is that changing? How much value added are we getting from water use? Looking at water use trends in places as diverse as Botswana and the Netherlands, and looking at value of water and thinking about water pricing in places like Namibia, the UK, and Jordan. So quite a few examples, all drawn from the CO Water Accounts Guidance. So wrapping this up, as we've been compiling these accounts and preparing a publication, which we'll have in review this fall, what might we use this for in the future? Thinking about how do we meet future water demand, what are the social and economic gains we could have from any policy changes, linkages between trade and the environment, and water resources, how much water are we importing and exporting from other countries, either directly or in the goods that we trade with the rest of the world, thinking about linkages with other natural resources and the overall value of water, and thinking about the value of the physical information that agencies like USGS generate, and how does that add value for decision making. So I want to close by in addition to any questions that you might have, if you have any ideas that you're willing to share with us on either the value or use cases you could see for water accounts in the U.S., we'd be really interested to hear that. And you can email me directly or type it in the chat box along with any other questions. If you see other potentially important national data sources that are consistent over time and have a time trend, those are probably our biggest interest in terms of data sources. And thinking more broadly as a community, how do we better manage data to produce more timely, complete, and accurate water account information that can help manage both natural resources and our economy. So happy to entertain any questions or thoughts about that or any broader questions that you may have from the rest of the presentation. Thanks so much for your time.